We're going to be measuring segments and doing more line constructions. 1.3. All right. How many of you have ever gone on a trip somewhere? Yes, everybody has, right? And so when you go on a trip, we all have the same question: how far is it, or how long am I going to have to stay in the car, or how many miles is it? To answer those questions, you have to understand distance. So we're going to be talking about distance in this lesson. And so distances can be measured in the most simplest form with a ruler. And so I want you to understand something, that distance is always positive. If I said that I went a -5 inches, you look a little confused right there. It could mean that I'm going to be going backwards, but that is no longer called distance. It's called something called a vector, and you might talk about that in another kind of math class. But the distance portion is the number, and that number is always positive. Okay, so what math symbol can I put around something that will keep something positive no matter if you have a negative number? Does anybody remember? They have these little bracket-looking things that are up straight. What's it called?
Absolute value.
Absolute value. Very good. So, it's absolute value. So if I asked you, I'm on the ruler from 3 to 8. So I'm going from 3 to 8. What's the distance? 5. So I could just do this two different ways. I could say 5. Excuse me. I could say 8 minus 3 is 5. But I could also say 3 minus 8. But now it would be negative, and I'd get that strange look like Brett just gave me a minute ago. So I would have to do something to make sure that I don't have a negative, and I would put that absolute value on there so that I would not get a negative value. Okay? So distance is positive, and I can make sure that by putting a positive. Personally, I usually just make sure that I take the higher number minus the smaller number, and I never have a problem. All right? All right, if we write the absolute, how do we write the mathematically using an absolute value symbol? We just saw it on there, okay? All right, we're going to use our ruler to measure some things. I'm going to actually pause this as we do that. Your rulers should hopefully have centimeters on one side and inches on another. And so let's do that at first. Here, right here. Your rulers, I'm going to actually increase this. Your rulers have very much this on it probably. In between here, in between 4 and 5, this would be 4.5. Mm-hmm. You guys with me on that? Mm-hmm. Okay. Each one of these little marks are an 1/8. Okay. So, back up. Let's tuck this off. So if you got to right here, you would be at 4 and 1/8. 4 and... Do I write 4 and 2/8 for that one?
4 and 1/4.
Yes, I reduced the fraction, 4 and 1/4. All right, but it's the same as 4 and 2/8. So what is, if this one is 4 and 1/8, this is 2/8. What's this one?
3/8.
And this one is
half.
4/8, which is a half. Okay, this one is 5/8. This one is 6/8, and we reduce it to 3/4. And this one would be 7/8, and then this would be 8/8, which is a whole, so it makes it a total of 5, right? Okay, so that's how your ruler works. It's not really that complicated. It's in eighths, and so when you measure this, we'll do this on your paper. You'll measure it in inches, and then you'll measure it in centimeters. We can get both of them. Let's compare them. We'll pause that. Okay, we paused that, and we came back, and now I want you to get your definition sheets out, and I want you to find where postulate or axiom and theorem is, and I want you to read those. A postulate is a rule that we accept without proof. It's also called an axiom. But a theorem is a rule or something that we have to prove, and we prove those using postulates. And we're going to see those in a moment with the a postulate that we're going to learn in this one. I want you to make sure that you go over these regularly so that you can make sure you have them in your head. Make sure you write, when we have these definitions, I want you to make sure you write those, keep going over those regularly. A way that you can go over these vocabulary words regularly is with a Quizlet. And I wanted to ask you if you had a quiz that you could go to. So we'll set that up so you can get to that more often. I think a couple of you had that as an option and you remembered to do that. All right, so we then opened our postulate books and you actually wrote down the very first postulate. It was the segment addition postulate. It was from those, you have some sheets that I gave you with all of the definitions and all of the postulates and theorems and formulas for this chapter. We read it, and the segment addition postulate said for any segment, the measure of the whole is equal to the sum of the measure of the non-overlapping parts. You wrote that into your postulate book as the very first one. There's going to be more of them that you will write in as we go along. We won't be taking time in making to write them down. You'll be making sure you keep up with that as we go along. We also drew a picture. We drew the picture if we have a segment here. We added it to the second segment, and it should equal the whole segment. So if this segment's 4, this segment's 10, the whole thing should be 14. Symbolically, we can write it like this. AB plus this BC equals the whole AC. And notice there's the little segments at the top of each of those. So we did this example. If that little piece is 5 and that little piece is 12, the whole thing should be the addition of 5 plus 12, which is 17. We also talked about that seems pretty logical that if I just stick those two pieces together, they should equal the whole. But not everything in life works that way. If you poured 2 cups of sugar into a bowl and then poured 2 cups of water on top of it, the total volume would not equal 4 cups. That just doesn't work that way with some of the substances. So addition with segments works that way, but addition with other things isn't always true. I'll challenge you to try that with the sugar and the water. Again, we have your AB plus the BC equals the whole thing. Here's where the distance formula came in. I had you copy it down on your formula, from the formula page to your notes, because you just get a lot of practice copying. It's good for your brain. And so there are times when you wanted to know from one city to the next how far things are, but then you also may want to know the distance between 2 points on a coordinate system. And so the example that we had was that we had the distance between these 2 points. To find the distance between these 2 points, we need to pick which one is 2 and which one is 1, because I want you to notice we have 2 x values, the first one and the second one, and 2 y values with a first one and a second one. I chose to have this one be the second point and this the first, meaning that this is x2 and x1. This one being y2 and this one being y1. So let's plug it in. This one is x2, so that's the -4, and x1 being the -1. So I wrote it like this. I took that parentheses and I put my -4 minus, because of that minus right there. I wanted that -1 to be there, and I needed the squared there because of the squared there. Bring down my plus. Now I have y2. y2 is the 3, and y1 is the 1. So we have 3 minus 1 squared. Don't forget your square root.
things are kind of overlapping. Let's give it a little bit of move and a little bit of zoom. We'll just give ourselves more room. This becomes a positive. Negative becomes a positive. I'll have -4 plus 1 becomes -3. I'm going to square it, so I'll get 9. 3 minus 1 is 2. 2 squared is 4. Don't forget your square root. 4 plus 9 is 13. I have a square root. Don't forget that. 13 does not have a perfect square root. Square root means something times itself that equals 13. There is a decimal value for that, but there's not a perfect, nice integer for that. So we're just going to leave it the square root of 13. I want to remind you that if the square root is a decimal, just leave it as a radical. Just leave it square root, like this one, square root 13. What we did was the Pythagorean theorem, by the way. That a squared plus b squared equals c squared for that right triangle was just the Pythagorean theorem. You can find this on your sheets at the back of the page. You can put this in your postulate book. You can also draw this picture on your sheets. But to use this formula, you must have a right triangle. Let's do this this one, the Pythagorean theorem way. All right? We're going to do the same one with the Pythagorean theorem. We have our point -4, 3 and -1, 1. We're going to plot it on this coordinate system here. The -4, 3 comes -4 and 3. So we have a point right there. And -1, 1 goes right there. And we're going to draw a line between them. And it's a segment. It doesn't keep going forever. But I want you to see the triangle that we have here. We have a triangle right here. And then we just count. This distance here is 2. This distance here is 1, 2, 3. And then we do the Pythagorean theorem with this being c. A squared plus b squared equals c squared. We're going to call a 2. 2 squared is 4. We're going to call b the 3, and 3 squared is 9. I want you to notice this looks very familiar. We had 9 plus 4 last time. We have a 13 equals c squared. The way you get that c squared, the squared off of there, is we square root both sides. Notice I have the square root of 13 again, and we just leave it, the square root of 13, as my answer. There we go. We talked about congruent segments. Congruent segments are segments that have the same length. The same length. These two have the same length. So we could write AB is congruent, and we make an equal, but that's more than congruent. Actually, that's more than equal. These segments are equal because they have the same length, but they're congruent because they're both line segments. And so to be congruent is more than equal. It's equal in length and the same shape. So AB is congruent to XY. You have those on your definition pages. So congruent segment means there's two segments that have the same length. And your symbol we looked up already. I drew it for you. Alright, another construction. I won't be doing it here in this video, but I will send you to some videos that do have them. I encourage you to ask as many questions as possible. Make sure you contact me if you have any questions. You need to make sure you find your homework. You're going to grade your homework. You're going to correct them and you're going to bring them back to class. Your parents will be giving you a quiz and grading it. You're going to bring that quiz back to class. I don't want you to forget that you have week 1, you have a construction assignment that I added to that. You can do it at any time, and it's short, and it can be done with any of the assignments. Okay. See you next week.